Ram Ram coders, I hope all of you are doing good. And this is our first English video. A huge demand was there to make editorial in English. So for the English audience, this video is being made. Okay. No doubt we will continue our videos in Hindi for our regular audience. Okay. So let me first explain you the question. The question says that let's go to the whiteboard. Okay. The question says you are given an array. Okay. And in an array, let's say I make a random array. Okay. At the end, you wish that in the entire array, two adjacent elements to be equal, there should be only one pair. What do I mean? Like in this array, these two adjacent elements are equal. Okay. These two adjacent elements are equal. Okay. So there are two pairs of adjacent element. But your target is at the end, there should be one pair or zero pair. This is your target. At the end, there should be one or zero pair of adjacent element equal. Okay. What you can do to achieve this target? You can take any two adjacent element and give them a particular value, any value, let's say x, whatever you wish, in between 1 to 10 to the power 9, any value you wish. For example, in this question, we can see there are two pairs of adjacent elements which are equal, right? But we want at least 1 or 0, right? So at most 1 or 0, right? So what can I do? If I take, let's say, if I take these two elements, okay, and I make them 4. So new array looks like 1, 2, 4, 4, 3, 4. And now you can see in this new array, only one pair of adjacent elements are equal and there's not an issue. So I did one operation to achieve this. So answer is 1. Did you understand the question? For example, if I say that this is my question. Okay. Now in this question, how many pairs of adjacent elements are same? This is one pair because both are 1. Another pair, both are 1, and 3 pairs, right? And I want to perform the required operation a minimum number of times and to make at most one pair of adjacent elements same, right? What can I do? What's the best for me here? Here I can do is, the best thing is 1, and I can convert them to, let's say, 5. 1, 5, 5, these two, 2, 3, 4, 4, 5, right? Let's say 6, any number, right? And usually we convert to such a number that doesn't exist in the array, so that from these two numbers point of view, for this new converted number point of view, we don't get any issues in future. Okay. Now these are 2, 4 and 2, 6 are there, but we want only one different element. So what can I do? I can, let's see, 1, 6, I can make this to 7, let's say 7, 7, 3, 4, 4, 5, and still there are two pairs, right? Now again I can set these two elements, I can make them 8, 1, 6, 7, 8, 8, 4, 4, 5. Still there are two pairs. Now I can set these two elements and make them again 9, let's say 1, 6, 7, 8, 9, 9, 4, 5. Now I believe that there is only one pair, 9, 9. So answer is 1 here. So not 1 here. Answer is how many operations did I do? 1, 2, 3, 4, and 5. I believe 5 operations I require to make this entire thing same. Okay, according to my need. And I think this was the shortest here. Okay. Now this is the entire question, and let's think how to approach. Okay. First of all, we can count how many pairs of adjacent elements are equal. This you can do easily, right? Now let's say if the array is something like this. So if we count how many pairs of adjacent elements are equal, there are 0 pair here. And since there is 0 pair, here answer is 0. We don't need to change anything because already it's 0. Okay. Now let's say if we count and that there is, let's say, 1 pair. Again answer is 0. 1 pair is allowed, right? We don't need to change anything. Okay. Now if we count again, let's say, and let's say there are more than 1 pair, obviously, but it's in a series. For example, 1, 2, 2, 2, 3, 4, 3, like this. Okay. Now there are 2 pairs, obviously, and this is a segment. A segment is same and no other segment is same. I believe like this will also go into this category. Okay. A segment is same. There's one segment which is same and rest all are independent. What can we do in this case? Like let's say there's a segment of length 3 of 2. How can I change it? I can make this to 3, 2, 3, 3. Now initially there were 2 pairs. Now there's only 1 pair. It's fine. One operation. If there are 4 2s, let's say, how can I do? Tell me what's the best you can do. You can take this 2 and make them 3, 2, 3, 2. Now there's only 1 pair, which is absolutely fine. Let's say there are 5 2s. What can you do? Tell me, what can you do here? You can set these 2 2, 3, 3, 2, 2. Again, there are two pairs. What can you do? You can check these two. 2, 3, and 4, 4, 2. Now there's one pair. So if there is a continuous segment which is equal and there's only one such segment. See, first we dealt with these two cases, then I told that okay, more than one adjacent pairs are same, and let's say that that's a continuous segment which is same, and that's the only segment. And the segment may contain 5, 6, and how many elements we wish. Okay. So the main point of saying it was, now see, if the segment is of 3 element, we need one operation. If the segment is of 4 element, we need one operation. If the segment is of 5 element, we need 2 operation. If the segment is of 6 element, we need, you observe that we need 3 observations. So what's the observation here? If the segment is of 3 elements, we need one operation. If the segment is of 4 element, we need one operation. If the segment is of 5 element, we need 2 operation. The segment is of 6 element, we need 3 operation. So yeah, you observe it correct. So we can check if there is if there is such a segment which is totally equal and there is only one such segment, so we can count how many elements are there. If there are 3 elements, we can see out 1. Okay, we need 1. And if there are 4 elements of anything except 3, we can see out what? N minus 3. That many operations are required to do it. That many operations are required to do it. Simple. Done. Now the last case, if there are many segments, that's the remaining case, right? Let's say 1, 2, 2, 2, 3, 4, 5, 5, 5, 6, 7, 7, like this. Now what can we do? Now see, a basic common observation you can say that this is a segment, and whatever I do at the end on this segment, I will have one pair of adjacent characters same, because I am adding one pair of adjacent characters as same. So at the end it will remain, right? So let's say I make them 3, 3, only 10, 10, let's say. So at the end one pair is there, right? And here also, whatever you do, whatever, at the end there will be one pair which is same. At the end here already there's one pair. So but still you have 3 pair. What can you do? Now the only trick or the only thing here is you can take these 2 elements and change, because these 2 adjacent are same. You have to change them. Now these 2 adjacent become same. You can take these 2 and change them. You can take these 2, and this is how you can go in a sequence. Just let's take an example. 1, 2, 2, 2, 3, 4, 5, 5, 6, 7, 7. I am saying that make them, let's say 8, 8. Okay. Now we have this same, this also same. What can I do? I can take this and make them 9, 9. Right. Now I can take this and make them again 1, 1. Whatever you wish, right? Now I can take them and make them 2, 2. I can take it and make them, see here, this was 2, 2, right? So I can make them 3, 3, right? 3, 3. Now I can take it and make them 4, 4. I can take them and make it what? 5, 5. I can take these 2 and make it 6, 6. Now you will observe that the new array looks like 1, 2, 8, 9. Again 1, 2, 3, 4, 5, 6, 7. This is our new array, right? 11 elements, yeah. 5, 6, 7, 8, 10, 10, 11. That's the only thing you can do. You have to take one segment, you have to make it unequal, and then you have to continue it so that to get an even result. And else you can't do anything, I believe, right? This is the algorithm, simple. So you can count the first segment which is unequal. You can count the first segment which is unequal, and here this was the segment, right? Then you can count how many operations you need, to make this different, and that you know. For 3 segment we need this many operations, for all those things you know, right? Now here there's a bit trick, not a trick, observation. If the segment is of length 4, if the segment is of length 4, you need what? Let's say, see, focus on the first segment. Focus on the first segment. Here I am saying that 1, 2, 2, 3, 3, 4, 4, 5. So I can make this unequal. Let's say 1 to 8, I make it. Okay. Now this index is 3. This index is 4, 5, 6, 7. 4, 5, 6, 8. Now tell me, to make it, what should I do? I should take these 2 elements, right? And I should make them whatever 9, 9. One operation. Then I should take these 2 elements and make them 1, 1 again. And I'm done, right? So what I'm actually doing at 3, this is a pair which will propagate, and it will propagate till 5. Because if it comes still here, then everything is fine. So what's the answer? How many times it should propagate? 5 minus 3, 2 times. Simple. If you look at the previous example, 1 triple 2 3 4 double 5 6 triple 7. Okay, 1 triple 2 3 4 double 5 6 triple 7. Right. If you look at this example again, I'm saying the same thing. You can make this anyhow. You know how to do all these things. Now let's say now at the end you get a pair here. Okay, and this index is 1 2 3 4 5 6 7 8 9 10 11. And now you want this pair to propagate and come to here, because here you're getting an equal segment. So what can you do? 7 minus 3, you need 4 steps. Now you want this pair to propagate and come to here. So because this is 11 and this pair comes like this up to here. So at the end you are getting one unequal segment only here. So it's 7 minus 7 plus 4 again. You need overall of 8 operations, or you can say you can count the last pair and you can just subtract them to get the total number of operations you need. This is the logic. And moreover, what can you do? See, in this case, if I talk about 777, at the end you will get, let's say, 799. But just a step before this, what was the state? If I tell you that just a step before this, the step 8, this would be the state. This should be some 8, any random number, and this will be a state, and then you will propagate again and you make it 799. But you don't need to do this. Just imagine the state before this last state, which I told you, 899. The state will be that this will be 7 and these two will be, the pair will propagate and come to here. And that's also fine, because still you have only one pair. The pair should at least visit till here. If the pair visits till here, then we are having these two are same. So the pair should visit till here. If the pair visits till here, then everything is fine. So because, and here, why did I say that? Because here the pair had to move on. When you talk about a last segment, the pair has to move to the I minus 1th element and it's fine. So you can see out answer minus 1, simple. Right? I think this is clear, right? Now this was the logic all, and I think I implemented it in a tougher manner. You just understood it, and while I explained you, I figured out some easy hacks for this. So even I believe if you have listened it carefully, you must have observed some easy hacks for this one. Now, if I go to the code part, see here. Okay. See, this is a totally bogus code. You can write a very simple code. Okay. What I have done, first of all, I have checked here. See. Yeah, I have checked how many segments are same. How many segments are same? Okay. And I told it, if there's no segment same, there's nothing equal, then C out 0. If the equal segment is 1, now I have to check its length. If the length of the segment is 2, then means there is only one pair which is equal. So C out 0. The length of the segment is 3, 2, 2, 2. You have to make one operation, right? If the length of segment is anything else, you have to make V0 minus 3 operation. And V0 stores the length of the segment, right? This you can do easily, right? Now, I'm just checking here. Okay, so the last segment, which was the first segment, which was same. That's I've stored it in previous. The first segment, which is same, 111, 2, 2, 3, 3, 4. So the first segment, which is same, I stored it here, and this was the first segment same, right? So initially, to change this segment, you need how many operations? V0 minus 2, right? See, to change this segment, you need V0 minus 2 operations. Let's say the segment length is 4. Okay. So how many operations do you need to make this pair come here? First you change it 1, 2, 1. Let's say 3, 3, 1. Now you change it 1, 3, 4, 4 times. So you need 2 operations. V0 minus 2 operation. Then you can continue from previous plus 1, right, from here. And then if you find some segment, so C is greater than 1, right? And if there is some segment, then you can just subtract the previous index, and where that segment ending, here it's ending. So I minus previous, and now the previous becomes this I. And this is how you continue, and at the end you see out answer minus 1. You see out answer minus 1 because I told you at the end you don't need to travel to the entire segment. You can just go and to this and then minus 1 at 1, right? So yeah, this was the code, and I believe these things are clear to you. This was not tough, but a good implementation. Okay. Okay. So if you understood this, it's good, and then do like, share, and subscribe the channel. And if you want me to improve on any part, then please suggest me. And this was the first video in English, so maybe I may have fumbled a lot, and I may have said some extra or something less. So I'm really sorry for that. Okay. If you have any doubts, you can come in the comment section, or you can join the Telegram group. So keep coding. Jai Hind.